let us start our closing session by thanking to all the speakers of this Ising lectures, and on this occasion also to the chairpersons who are here.
May I ask?
So now we start our closing as usually, and if possible, if you want, those of you who wish, please make your video on, and we will be just discussing as if we are in the same room. And so there is no special plan for this closing session. Only I want to start. All of you, when you were delivering your talk, you were thanking to the organizers, and I want to use this occasion that organizers are here. Namely, these are Oksana Dobush, this is Mariana Krasnitska, this is Dmitro Shapoval, and this is Danilo Dobushevsky. So 4 young scientists, 2 boys, 2 girls, 2 men, 2 ladies from our institute who organize this sitting, these Ising lectures, and I am very happy that they continue doing this because, you know, it gives the hope for future. The hope for future for our Ising lectures, and also your participation of all of you during these lectures give us confidence in our future, because in a way, doing physics together with us, give us the feeling that we are together, and together we stand in spite of very hard times, in spite of the war. So thank you very much that you are with us. That's first thing. And another thing, now the stage is yours, the stage is ours, all of us can discuss. Also, it was a suggestion, I think, of Professor Kuzetsky to discuss some scientific matters which might have originated already during the discussions. You are welcome. Just start by voice, or if you want, just make, if it will be numerous of you, I will have a look who is raising hands. You're welcome.
Maybe may I say a few words in disclosure before?
Yes, please.
So these lectures are indeed. So they started in 1997. So which means that it's the 27th event of this ring, and just shortly speaking, I would say that I am looking forward for the next this lecture. And thank you very much. And this indeed, this is a very important event. I think that in this area of science, I mean, this in interdisciplinary. And thank you, Yurko, once again for your efforts and for your stamina to do this all this time. Thank you.
Thank you.
Maybe all of us join me with this.
Yes, thank you.
Yes, definitely.
Thank you.
Definitely, and it is very good that you keep on doing it, and I hope that to participate or to share something like this in 10 days, in 10 years from now as well. So I hope indeed that it will go and carried, your initiative will be carried further by younger, beautiful Oksanka. And so,
yes, you know, and what is important, that initiative is permanent and it's coming from different people. So I am very happy that I see on the screen now Professor Kobe, who initiated it by going to Ising, by visiting him and his wife, and by writing the paper. It was a paper in Journal of Statistical Physics, and then it was the paper in the Brazilian Journal of Physics about Ising. And you know, even on our side, we have the voices of Ernst Ising and of Johanna Ising, who are reciting Goethe, Prometheus. So Professor Kobe recorded them reciting Goethe, and it is on our side also, you know. So then at some point it was initiative, I think, coming from Mariana Krasnitska and then from group of young people of our institute. They decided to publish the book about Ising lectures. So they collected the books, they found the money, they found the printers, they did design, and they themselves published the book. And some of you have this book as a lecturers, and the book is online. Then we decided, or even before, we decided to publish first volume of Order, Disorder, and Criticality. Then it was about phase transitions and critical phenomena. We didn't know that it is the first volume because we thought it is the book. In several years appeared the second volume. Now we are almost ready with volume number 8. Actually, Professor Teuber, who is here, is one of the courses he already submitted to volume number 8, and his chapter is available online on the archive. So this volume number 8 of Order, Disorder, and Criticality will be published this year by Well Scientific. And I hope that lecturers of this workshop in this year will submit to volume number 9, and that's how it goes on. At the beginning, it was criticality, phase transitions. Now it is criticality and complex systems. So the life prompts in which direction to move. And it is very different. You know, second session yesterday, it was cities. First session, it was between physics, mathematics, who was Pavel, and society and kind of data analysis, and also some mathematics, which was Fariba. Today it is hardcore physics, you know. But somebody would say it is very different. But the point that we find common language. Today there were more questions from mathematicians. I am weak in this direction, but it was very interesting for me to follow this discussion. And we have the same language. We have the language of scaling, of universality, of effective behavior, of singularities, and we repeat it every day. And in this sense, we are the same community, and I think it gives fun, and also maybe it is useful.
Yeah, it gives pleasure, yes, indeed. Pleasure, certain cross-fertilization. That's true. And I hope to be able to come to Lviv in person.
We would be happy. We would be happy if you
Which
come.
city?
Actually, some of you are coming to Lviv. It was a colleague from the United States today and yesterday, Niklas Manke, who will come in a week or in a month to us. Then it was a colleague from ANS recently who came to Lviv. So still it is some flow of people from the West coming to Lviv, but of course it is now.
You see, last 2 days with our secretaries, we were occupying with the mission of Maxim to Paris. And in CNRS, they confused. They thought that he is going from Paris to Lviv. And it went up to the high functionary of defense who said, no, I will not approve this mission.
Yeah.
Yeah, of course, it's clear, because nobody wants to have to be
To
sued.
take responsibility, yeah.
Yes,
To take
yes.
responsibility for this. The same is in my university.
I was once going to visit Israel during Intifada, and so I got an answer, no, because we don't want to pay for repatriation of your body.
Yeah.
So
may I ask Pavel something, because I thought of this a couple of days after his talk, concerning the talk.
Absolutely.
May I?
Yeah, absolutely. Yeah, I said absolutely. Yeah.
Do I remember well that the front propagation in your talk was so the time was t to the power square times 1 over d plus 2.
2 divided by d plus 2, exactly.
2 divided by d plus 2.
Yeah,
So
somehow you may remember
mentioned,
just 2 to the 2/5, which is, 3D, which is the most important case, and how is this atomic explosion or super, yeah.
Now let us consider the following situation. So you have R, just real axis, and you have rods, hard rods distributed somehow over this, and they are quiescent. And then you take one of them and make it moving.
Yeah.
let's say to the right, okay?
Yeah. Yeah.
And then this particle hits, after some time, it hits the neighbor.
Mhm.
It cannot penetrate.
Yeah.
If we assume that the collision is elastic,
Mhm.
and assume that the kinetic energy, this is the only energy which is here, is conserved, then we immediately obtain that the first particle stops
Mhm.
and the neighbor starts moving with exactly the same speed.
Absolutely.
Then this new moving particle does the same with its neighbor on the right,
Yes.
and so on. And the speed is always the same. So, which
Yeah.
means that now this front moves with constant speed, and then its position is the speed times t. So, which means that in dimension one we have t, not 2 divided by 3.
So absolutely right. I tried, and it was easier to me than to Maxim because really much less in my model to definitely said it a few times, but okay, let me repeat it. So you absolutely right, and that is actually the general feature of 1D. It's pathological, and so but here we can fight this the following. We just distributed masses in all other dimensions. They are totally identical, but in 1D we still say you can consider rods, or you can consider just point particle, but masses are distributed, not just the same mass one.
Okay, I understand.
Yeah.
That's clear. That's
And
clear. So
typically we
now
have masses like 1 and 2, something like that,
yeah.
and it's enough. It's enough for relaxation. And even you shoot particle to the right initially, after a while, it's actually propagates like t to the 2/3, and everything become more and more symmetric. But in that case, there are a lot of particles moving within t to the 2/3. But what you said, when it's mass is exactly equal, it would be always just one particle moving. Yeah, so there is no,
As
you
if
can call it
effectively.
front, but it's sort of soliton, sort of a soliton which just propagates here. That's
And then, Pavel, Semi, and what about making the masses random?
that what in 2008, when we studied it, we considered 2D and 1D. We did masses random.
No, in one dimension. Hmm?
Distributed them in 1D between like 1 and 1.2, something like that. And I was actually.
Does it depend on the distribution of these masses?
Yeah. I was asking this my Indian collaborators why they consider this. They call HP, whichever. So it was like just two masses. Why it's enough? And I was still afraid. For instance, if masses ratio, for instance, something special like golden ratio, sometimes things are very very different. Yeah, because here there are really almost number theoretical properties. But they simulate, they see that everything is cool. But definitely, for instance, for the problem when it was half line occupied initially, they can go. We consider like mass 2, 1, 2, 1, 2, 1, or 1, 2, 1, 2, and we hit the left particle. And if it's 2, and if it's not 2, but like 3 half, things are different. Amplitudes are different. But actually, position of the front, for instance, where there is shock wave, is seems numerically whichever is kind of doesn't notice this difference. But some details, how they, for instance, the very first particle, that's definitely different. So there are some subtle sort of mathematical, as for instance, Yuri said somehow, yeah, really billiard aspects, which can be some details depending on details, and some not depending on details. And it's a bit of a mystery why, somehow hydrodynamics somehow really forget about some of the details. But you're absolutely right. Yeah, it's subtle, but mostly in 1D. Yeah.
And then in dimension 2, for example, I understand that this attenuation or slowing down is because it is impossible to heat to make this almost impossible to make this central heat where the heating particle stops. Otherwise, the their velocities after this collision should be just orthogonal and but maybe non-zero. And they change the direction, and then this direction they changes again, and this makes the slowdown. And so this means, but each time we have, is it maybe is it important to take into account secondary collisions? I mean that a moving particle collides with a moving particle, not with only quasar, but also with moving particles.
It's absolutely,
Is it-
absolutely. It's absolutely taken because, for instance, when we have this growing, more or less, droplet of moving particles, inside they keep colliding, they're all moving, and only this outside, which actually kind of shrinking, but it's because outside there are quasar particles, and when they hit them, they all start moving, and so of course we take into account all collisions forever, for sure.
All collisions.
For sure.
Because
yeah.
if one ignores these secondary collisions,
Yeah.
then it might be this picture might be embedded into some binary fission. It's binary fission like atomic reaction. Binary fission, because one is, and then it makes two moving particles, and so on and so on. So it's for me, it's fascinating.
And also you see that one of the reasons, first of all, almost all collisions occur more and more inside this bulk, not on the surface. And second of all, because overall energy is conserved and more particles, they move more and more slowly. So yes, there is this still process, as you are saying, like you hit particle and another start moving, but actually the approach velocity becomes smaller and smaller with time. And so, but overall, the number of collisions growing, and trivially growing, yeah. And again, it's a bit almost against intuition. But for instance, this exponent is independent. You can have particles which occupy 1 millionth of the volume or 1/10 of the volume. But this exponent doesn't care about it.
Do you know mathematical works on this?
Essentially little. I told you, if we have 3 particles, for instance, and you just
I know this works.
how many collisions? It's 4. And if 4 particles, nobody knows, and people studied if it's n particle, when n becomes larger and larger, but finite. Maximal number of collisions is finite, and that was actually 10 years a problem, and it was proven eventually at the end of 70s. But upper bounds are very bad. Upper and lower bounds, they immediately fly ahead. Yeah.
I know these people who work with billiards.
Yeah.
So
mostly, no, it's beautiful things they do it, but mostly they consider, for instance, the most famous work by Sinai himself, but inside the stadium, it's just 1 particle. So sometimes they have 2. Yeah. So in here, infinitely many. Yeah. But it's for instance, also if you somehow consider more physical and you say that you have these particles, but they somehow have maybe electric charge and magnetic field, so they go not straight trajectories, but circle. It's very little known, little known.
I see.
So in fact, right now we are present during new tradition, which is being born during Ising lectures. We have nice long discussion on scientific matters at the end of the conference. And especially it's interesting because, it's we are doing this after last lecture, and we are discussing one of the first lectures, the first day. I attended both, so it was especially of interest for me. But what I want to say, it is another tradition which comes from different field, from music. And I don't know the name in English of this symphony. Is it Symphony of Joseph Haydn? And in Ukrainian, I would say Farewell Symphony. And it looks like that each musician stops playing and switches off the candle, and then less and less candle on the stage. So I noticed that some of participants also, kind of,
the history.
Step by step, they are starting to leave us. So before we implement this tradition,
one doesn't want to do this, so we should
of leaving one by one. Let
Do you
us.
know why did it happen? Because Haydn and his orchestra was stopped being paid. And
Yeah.
that is why it happened like this. It was
That's how
really
we
bad.
Ukraine. That's how we. That's okay. So, if nobody wants to say something in addition for the closing of our session, if it is not the case, I want to welcome you very much in 1 year. And as Taras Briggs, our director, told at the beginning that last year and last year he told, and the next year should be the peaceful year, and you come in person. That's our hope. That's our hope, and we repeat this, and we do whatever we can to implement this. So welcome to Peaceful View next year, and thank you so very much for those who lectured, for those who put questions, who attended, and again to those who organized, Oksana, Mariana, Danilo, and Dmitro. Thank you very much.